So hi everybody. So in the last class we are discussed about the first order partial differential equations. So we have studied already the solutions for the first order partial differential equations like linear partial differential equation, semi-linear partial differential equation, quasi-linear partial differential equation, and also non-linear partial differential equation using different kinds of methods like Lagrange if the equation is in quasi-linear form, and Charpitz if the equation is in non-linear form, and also the method of Cauchy characteristics gives the solution for all kinds of equations, and also separation of variables. Okay, now we are going to the new chapter, second chapter, that is second order, right? So linear equations with variable coefficients. Okay, linear partial differential equations with variable coefficients. Once variable comes into the picture, right, so you know the difficulty in finding the solution, right? So here we are going to study the second chapter as second order linear partial differential equations with variable coefficients, right? The general form of the second order equation is given by r into small r plus capital S into small s plus capital T into small t plus capital F of x, y, z, p, q is equal to 0, right? So call this equation as number 1. So as you studied in first order, the equation of the form p into small p, q into small q is equal to r. So small p is first order derivative with respect to x. Similarly, small q is first order derivative with respect to y. And capital P, capital Q and capital R are functions of x, y, z, right? So in the similar manner, the second order equation is given by in this form r into r, s into s, t into t plus f of x, y, z, p, q is equal to 0, where small r means del square z by del x square, means the second derivative with respect to x, and small s means del square z by del x into del y, means partial derivative with respect to x as well as y, and small t means del square z divided by del y square. Okay, and you know what is p and what is q, right? So this is the second order partial differential equation where capital R, capital S, capital T are the functions of x, y and z, right? X, y, and z also. Sometimes if z comes, then the equation becomes non-linear. They are functions of x and y only. Now, instead of writing this equation in this form, I am going to write it in different form, like by taking these second order derivatives as some differential operator L of z, or so simply L of z plus f of x, y, z, capital F of x, y, z, p, q. So must be equal to 0. Then what do you mean by L of z? L of z means r into r, s into s plus t into t, right? So this is the form of the second order differential equation. Here our intention is to transform the equation from one form to another form. We are going to transform, because in one form if it is difficult to find the solution, then in other form you can find the solution easily. Means we are going to reduce the equation from, we are going to transform, not reduce, we are going to transform one form of the equation to another form. Means if it is second order, there will be our transformed equation also in the second order, but the form of the equation, the nature of the equation will different. So for that equation you can easily find the solution. But to transform the equations, we are going to take some transformations for the original variables, like x and y are the independent variables and z is the dependent variable. For independent variables also we are going to take the transformations. Similarly, For dependent variable also we are going to take the transformation. Here for the independent variables we are going to consider the transformation as xi comma eta. So instead of x comma y we are going to consider the transformation variables as xi comma eta. Here both xi and eta are functions of x and y. Here both xi and eta are functions of x and y. This is the transformation for the independent variable. Similarly for the dependent variable z is a function of x and y. For this I am going to consider the transformation as phi of xi comma eta. Instead of z I am going to consider phi. So instead of these two original variables I am going to take the variables as xi and eta. Now by taking this transformation you can transform the equation 1. So this is the original equation into the different form. Let us see. So what is the different form? Because to see that you have to find the derivatives. So first you have to find what is del z by del x, del z by del y, del square z by del x square, del square z by del x into del y, and del square z by del y square. Means you have to replace the derivatives exist in the original equation by the new derivatives. Let us see how. So we have to replace the derivatives. Now as a first instance I am going to find the first order derivative as del z by del x. Okay, del z by del x means your p. So p is equal to del z by del x. You have to find the expression for this derivative. As you know the transformation is z of x comma y is equal to phi of xi comma eta. Means so here as you know phi is a function of xi, phi is a function of eta. But xi and eta are functions of x and y. You should remember those things. Now the derivative will become del phi by del xi because phi is a function of xi, but xi is a function of x. That's why del xi by del x. Plus similarly phi is a function of eta. That's why it becomes del phi by del eta. Again eta is a function of x. So this is the derivative. This must be the derivative for the first order derivative. Similarly, using this first order derivative, you can, in the similar manner, you can find the first order derivative del z by del y also. That is nothing but your q. Here, instead of x, there will be y. Simply because xi and eta are functions of y also. That is, they are given by del phi by del xi and del xi by del y plus del phi by del eta into del eta by del x. So this will become the first order derivative with respect to y. Okay. So now using these two derivatives you can find what is del square z by del x square, del square z by del x into del y, and del square z by del y square also. Let us see the second derivative. That is nothing but your capital R. It is given by del square z by del x square. Means, so you have to differentiate this once again. Is it right? Second derivative means you have to differentiate this once again. Right? So here it is given by, so let it be some f. ಇದನ್ನ ನೀವು ಒಂದು ಸ್ವಲ್ಪ f ಅಂತ ಕರ್ಕೊಳ್ಳಿ. ಸೊ ಏನಾಗುತ್ತೆ del f by del xi into del xi by del x plus del f by del eta into del eta by del y. Is it right? If it is f, the total derivative is taken as some f. So then by again you have to differentiate f because you have to get the second order derivative. Now the derivative is given by df by d psi into d psi by dx plus df by d eta into d eta by dy. Is it right? Now you have to replace f by this derivative now. So this will become, this is equal to del psi by del x, take it outside. Now differentiate f with respect to xi. Then this equation will becomes del square phi by del xi square. Is it right? Del square phi by del xi square plus So you have to apply, I mean here is also xi, this is also function of xi. It is just like product of two functions. That's why you have to apply product rule. Okay. Del square phi by del xi square into del xi by del x plus del phi by del xi as it is. This will become del square xi by, so I mean del square xi by del x square. Okay. You are differentiating. Similarly, so you are going to differentiate this also. So you are going to get the derivative as, after simplification, del phi by del xi into del square xi by del x square plus del phi by del eta into del square eta by del x square plus del square phi by del xi square into del xi by del x whole square plus 2 times del square phi by del xi into del eta into del xi by del x into del eta by del x plus del square phi by del eta square into del eta by del x whole square. So this will become the second derivative. This will become the second derivative. Similarly, by differentiating, so I mean q with respect to x, you are going to get s. That means del square z by del x into del y, or p with respect to y. You can differentiate p with respect to y or q with respect to x. Both are one and the same. So both will give the same result. You are going to get the derivative as del phi by del xi into del square xi by del x into del y plus del phi by del eta into del square eta by del x into del y plus del square phi by del xi square into del xi by del x, okay, into del xi by del y, okay, plus del square phi by del xi into del eta whole thing into del xi by del x into del eta by del y plus del xi by del y into del eta by del x, okay, plus del square phi by del eta square into del eta by del x into del eta by del y. Okay. So ನಿಮ್ಗೀಗ ಐ ಥಿಂಕ್ ತಲೆ ಕೆಡ್ತಾ ಇರಬೇಕು, ಇದು ಎಲ್ಲಿಂದ ಬಂತು ಏನು ನಿಮ್ಗೆ ಆಗ್ತಿದೆಯೋ ಇಲ್ವೋ ನನಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ. ಬಟ್ ಶೂರ್ while doing the problems surely you will get so surely you will understand how to differentiate, how to get the derivatives for these, right? ಈಗ ನಿಮಗೆ ಏನೇನೋ ಕನ್ಫ್ಯೂಷನ್ ಅನಿಸ್ತಾ ಇರ್ಬೋದು, ಇದು ಹೆಂಗ್ ಬಂತು, ಇದು ನಿಮಗೆ ಅದು ಅಷ್ಟು ನಿಮಗೆ ಡೀಟೇಲ್ ಆಗಿ ಗೊತ್ತಾಗ್ತಿಲ್ಲ ಅನ್ಕೋತೀನಿ. ಐ ಆಮ್ ಶೂರ್, ಯಾಕೆಂದ್ರೆ ಇದು ಎವ್ರಿ ಇಯರ್ ಎವ್ರಿ ಸ್ಟೂಡೆಂಟ್ ಹ್ಯಾವ್ ದ ಸೇಮ್ ಡೌಟ್ಸ್. ಸೊ ಇದು ನನಗೆ 20 ವರ್ಷದಲ್ಲಿ ನೋಡಿದ್ರೆ ಎಲ್ಲ ವರ್ಷದಲ್ಲಿ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಇದೇ ಪ್ರಾಬ್ಲಮೇ ಇರುತ್ತೆ. ಬಟ್ ವೈಲ್ ಡೂಯಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ 100% you will get, so you are going to know how to find the derivative. Similarly, you are going to get t means del square by del square z by del y square. So after the derivative, finding the derivative, you are going to get del phi by del xi, okay, into del square xi by del y square plus del phi by del eta into del square eta by del y square plus del square phi by del xi square into del xi by del y whole square plus 2 times del square phi by del xi into del eta into del xi by del y into del eta by del y plus del square phi by del eta square into del eta by del y whole square, right? So these are the derivatives. Now with your hand you have the second derivative with respect to x, the second derivative with respect to x and y, the second derivative with respect to y, and the first derivative with respect to x and first derivative with respect to y. Now by substituting all those in this equation, in the first equation, you are going to get, so by substituting all those in the given equation, you are going to get, so So one simplified equation, so in the form a into del square phi by del xi square, okay, plus b into del square phi by del xi into del eta plus c into del square phi by del eta square plus some function of xi, eta, phi and then del phi by del xi and del phi by del eta equal to 0. So now you have a doubt. So what are A, B and C? So your A means after substitution. So you have taken the substitution as some capital R means del square. So capital R into del xi by del x whole square plus capital S into del xi by del x into del xi by del y plus capital T into del xi by del y whole square. After substituting those derivatives in the first equation, you are going to take the substitution of these terms as some capital A and capital B as 2 times r into del xi by del x, del eta by del x plus s by 2 into del xi by del x, del eta by del y plus del xi by del y into del eta by del x, okay, plus t into del xi by del y into del eta by del y. So this is about B and C is given by capital R into del eta by del y whole square plus S into del eta by del x into del eta by del y plus capital T into del eta by del y whole square. So these are the substitutions I have taken. So while simplifying the equation. Now, so with these substitutions you are going to get a new equation. Okay. If you are going to consider wave equation corresponding to that, you are going to get one more new equation. Similarly for Laplace there will be one more. Similarly for energy equation, heat equation, there will be one more. And the obtained equations are called as canonical forms. Okay, canonical forms. So you know what are canonical forms? Canonical forms like parabolic, okay, parabolic, hyperbolic and elliptical equations, right? So in the either of these three cases you are going to get the one of them by taking the transformation. So let us see when the parabolic equation will exist, in what circumstances the hyperbolic equation will come, similarly elliptical equation will come. So there will be three cases for the classification of partial differential equation. That depends on the discriminant. Discriminant is given by delta is equal to s square minus 4rt. So these are the coefficients in the partial differential equation, right? So coefficients in the partial differential equation. If this discriminant is positive after the substitution, then the nature of the given equation is hyperbolic. If it is positive, then the nature of the given partial differential equation is hyperbolic. In this case, the roots of the quadratic equation are alpha square plus s alpha plus t is equal to 0. This is the quadratic equation with the help of the coefficients of second derivative r s t. R alpha square s alpha plus t is equal to 0 are real and distinct. For the hyperbolic case, the roots of the characteristic polynomial are real and distinct, and the canonical form should be of the form del square phi by del xi into del eta, means except the second derivative, all the second derivatives get vanishes. Only this derivative will remains. Okay, that is so called hyperbolic case. Then how do you find xi and eta? For this, to find xi and eta, you are going to consider the relations del xi by del x is equal to lambda 1 into del xi by del y and del eta by del x is equal to lambda 2 into del eta by del y. Then what are lambda 1 and lambda 2? Lambda 1 and lambda 2 are nothing but the real and distinct roots of the characteristic polynomial what we have considered here. Okay. So by finding the characteristic roots, so with the help of those you are going to get the expressions for xi and eta. With the help of xi and eta you are going to transform the equation, right? Then after the transformation the remaining equation will be of the form, so del square phi by del xi into del eta is equal to f of xi comma eta comma phi del phi by del xi and del phi by del eta. Means all the second derivatives with respect to xi and eta except this term get vanishes, and so you may have the first order, any first order derivatives, that doesn't matter. Here the main thing is second order derivatives only with respect to, this derivative will remain, and other derivatives like del square phi by del xi square and del square phi by del eta square will get cancelled. So they get vanishes, right? So this is about the first case, and this case is nothing but your hyperbolic case. If the equation is in the hyperbolic form, the second order derivative must be this only, and all other second order derivative get vanishes, and there may be any other first order derivatives, but all the second order derivatives except this one get vanishes. This is about the hyperbolic case. Next, case 2. In this case, if the discriminant s square minus 4rt is equal to 0, so if it is equal to 0, then the nature of the equation is parabolic. Okay, if it is equal to 0, then the nature of the equation is parabolic. In this case, the roots of the characteristic polynomial same, r alpha square plus s alpha plus t. This is the characteristic polynomial. For this case, for hyperbolic, they are real and distinct. But for parabolic case, the roots are real and repeated. Okay, for this case, the roots are real and repeated. So, as in the case of hyperbolic, we are going to find either xi or eta. We are going to find only one, because lambda 1 and lambda 2 are not different. They are same here. That's why we are going to find either xi or eta, any one of them. So with the help of these equations, any one of them, remember it, either xi or eta. And so the remaining is going to be predicted. Remaining is going to be predicted such that, so how you are going to predict? You are going to predict the second order derivative must be, del square phi by del eta square remains. Means all other second order derivatives get vanishes. Okay. So you are going to find either xi or eta, only one, and you are going to choose one more such that choose ಮಾಡ್ತೀರಾ, all the second order derivatives get vanishes except this second order derivative. Except this derivative, all other second order derivatives get vanishes, right? This is equal to same f of xi eta phi del phi by del xi and del phi by del eta. Means, so you may have any first order derivatives, any functions, that doesn't matter, but only it matters about the second order derivatives. This is only the second order derivative remains in the equation and all other get vanishes. Okay, this is for the parabolic case. And in the case of, case 3, delta means discriminant is s square minus 4rt is less than 0. One is greater than 0, one is equal to 0. Now at the end we are taken, so it is less than 0. In this case, the nature of the equation is elliptic. Okay, in this case, the nature of the equation is elliptic. Okay. For this, the roots of the characteristic polynomial, same characteristic polynomial, but the roots of this polynomial will become complex conjugate pairs. Okay, ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಜುಗೇಟ್ ಪೇರ್ಸ್, ಇಲ್ಲಿ ರಿಯಲ್ ರೂಟ್ಸ್ ಬರಲ್ಲ. ಬಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ xi and eta as same in the first case, means as same in the hyperbolic case you are going to find both xi and eta. But by taking this substitution, your canonical form will be in the form of complex numbers. Okay, so there you can find complex numbers. That's why to avoid those, again you are going to take one more transformation as some alpha is equal to 1 by 2 into eta plus I, and beta is equal to I by 2 into eta minus I. I am going to consider one more transformation to avoid the complex number, as alpha is equal to like this and beta is equal to like this. Then the canonical form so will be obtained as del square phi by del alpha square plus del square phi by del beta square is equal to f of alpha beta phi. So del phi by del alpha, del phi by del beta, right? Here these two second order derivative will remains, and with respect to alpha and beta get vanishes, and there may be different first order derivatives. These are the three different cases you are going to get. You are going to get the required canonical forms. So let us see the examples, okay, for these cases in the next class. So by this I am going to wind up my lecture today. So ಇದನ್ನ ನೀವು ನೀಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ, ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಒಂದು ಸ್ವಲ್ಪ. ನಾಳೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡುವಾಗ ಇನ್ನು ನಿಮಗೆ ಕ್ಲಾರಿಟಿ ಸಿಗುತ್ತೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.